Okay, thank you. Thank you very much for inviting me. I'm glad to be here. First, I would like to ask you these questions, like it sounds familiar to you that a small change implies a new build that takes a lot of time, that you're solving an incident in a business context, and then you stop all development related to a different context. With increase the size of the code repo, it's harder to work on it. It's expensive and hard to scale the application because it implies a replication of a heavy process, or outdated dependencies require a heavy maintenance effort. Because if you are facing this, or if it sounds familiar, probably you're facing the challenges of an overweight monolith. That is something very common I have seen as a professional. If you are considering to move to microservices, or this sounds familiar, or you are already in this journey of evolution, this talk is for you. I am a tech principal at ThoughtWorks. I work in Chile, in Santiago. I have worked with multiple clients with different architectures. I'm really interested in API ops, OpenID Connect protocols, how to connect ID authorization with API management, service mesh, cloud architectures with Kubernetes. And especially I like the fact that you can use technology to solve business, to merge both things. First, let's begin with what is a microservice. Probably this is very known by you. You're already working on it. So basically, I commented about the big process. Microservice is a small process, an independent service, when you have just one functionality, and that way you scale that functionality. And it sounds really simple and good, and there is a clear advantage instead of having something really big. So the question is, why not start directly with microservices in that case, if you know all that benefits that it will bring? And in general terms, in the clients I have worked on, what we see, it's usually hard to define the boundaries. It's the hardest part, to create an architecture defining those boundaries. But the monolith provides you those boundaries as you grow it. And then when you have them defined, then you can split them and generate this microservice architecture. It will imply also that you need to generate those boundaries in the monolith. And what conditions do we need to think about this evolution of microservices? We require also DevOps culture, monitoring, provisioning, the ability to deploy quickly in order to be able to have microservices. Also, another way of seeing it is thinking about the principles we need to have, right? The most hard thing, as I commented, is to align it to a domain. But additionally, we need automation. We need to hide the implementation details, decentralize all the things, make it highly available, deploy it independently, and isolate the failure. Those are the principles we need to follow. And what I have seen in the clients I have worked on, usually when you come there and there is a monolith, how to begin with, how to start with this evolution, what patterns can I apply? And I will refer to domain-driven design concepts in the rest of my talk, but I won't stop too much time in this slide. So if you want, you can review later, or probably you had already reviewed domain-driven design concepts. These are very known to you. If not, you can check this later. And I will begin with the first pattern that I have seen applied, that is the repository with anti-corruption layer as a bridge to the legacy model, or that Eric Evans called it the ACL bake. What you do is basically you first begin with the domain, as I say, the initial part, right? I define the context and I define what is my use case. Remember all the principles. I'm beginning with the business domain. I create the microservice, and a traditional hexagonal architecture of my microservice will be business logic, some repositories, some DB adapter, the database, and some other ports and adapters depending of the nature of my microservice. But the clue here is, instead of having a database, I will have an anti-corruption layer that will allow me to connect to the monolith. I replace the database with the anti-corruption layer. Again, a typical structure of anti-corruption layer, that is coordinator, translator, to make this communication possible. And the point is, I'm creating my microservice, but I'm breaking some of the principles I commented from the beginning. The next step I need to do is synchronize the monolith and the microservices. For doing that, then I add the database, the DB adapter, and now I have 2 entry points in my architecture. So what I need to do is keep both in sync. And I'm referring to event retrofit because sometimes the monolith, it's not made in a way that it's natively easy to connect to events. So I will need to do some component there. Then the second pattern, and probably it's also known for you, is how to use the Canary release for doing this incremental substitution. And based on the fact that Canary release is this rollout of functionalities based on business impact, we follow this in principle and begin to change the amount of traffic we have. What is important here is to have automation for doing those. I have the monolith, I have the event retrofit, I have my microservice with the anti-corruption layer, the pattern I just mentioned. And what I'm doing now is something really simple. I have a load balancer, so I'm changing the amount of volume of requests per each of these entry points. And that way, I can eventually remove the dependency I have in my monolith. So I stop the traffic to the monolith, and then I can continue with this evolution of the architecture. Then I will move to the strangle pattern, and hopefully you have read about it, probably you have applied it. The idea is to think about the monolith and think about, okay, if there is an effort about taking this functionality, which are these functionalities? Those are the questions you need to make to yourself. Which one change more often? Which one provide me a competitive advantage? Which one are core to my business? And from then decide where to apply the same principles I just commented before. Where to begin with the creation of these microservices, begin with the ACL bucket in a way to connect to it, and begin to extract all of these functionalities. And the idea to prioritize is because usually we have some limit time, and there is a cost of change when you are evolution, when you have this journey of evolution in your architecture. The good part of the strangle pattern is actually that you reduce the risk of making an abrupt change, and you actually choose what provides you more value, what has more frequent releases. But we shouldn't underestimate. I had worked with different clients. This journey is really similar in different clients, what I have seen. And usually we are talking about a multi-year project. That's why it's essential to prioritize. And also I would like to connect this to the challenges we face when we are doing this evolution, because in a monolith, we are talking about a package and class level communication within the same process. While we, in a microservice architecture, we are talking about a communication that pass through the network. And because of that, we face other challenges like managing timeouts, managing error responses that we have in the communication. And with the scale, like we begin to apply all of these patterns, we begin to extract more and more microservices, these challenges increase. And then we begin to see capabilities that are repeated service to service. In a microservice, following the principles I commented, we require traffic management, retry rules, security, metrics generation, and tracing. Those are very common to what I need. None of them are business logic at all, but they are part of the principles, and for that, indispensable in my microservice. In the complete ecosystem, I require in all of the microservices I'm extracting from the monolith. And then service mesh come to play. And I like working with this approach because it allows us to generate this commonality and to generate this infrastructure layer for these common capabilities. And using a sidecar proxy, that is one of the alternatives that the Consul allow us. For example, caches the certificates in the mutual TLS communication, and having the servers that handles all the the rules in this communication, it's very helpful. That allows you to focus in the code related with the business and focus in extract microservices aligned to the domains. Talking about service mesh, and in this journey that I'm sharing with you what I have seen, it's very useful in the migration to cloud scenarios. I saw in the agenda there was another talk that I think it was going deeper on how to have these hybrid scenarios, but I think especially Consul, it's helpful in the sense that you can have a virtual machine and you can have a cloud with Kubernetes, for example, and you can provide this layer of abstraction while you are migrating, while you are strangling this monolith. The other benefit I see is that usually that way you allow the teams to not repeat these commonalities in a custom way. What I have seen is, for example, people trying to validate a JSON Web Token in the communication just to realize they can do with the service mesh configuration. And when to decide to start events, this, as I commented, this is the journey of what I have seen in different clients. And recently I have seen more interest in moving from a synchronous communication to an asynchronous communication. And I will begin with the first pattern I have seen in this process of moving from a monolith to microservice, that is the API composition. I have seen this very often used, especially when we are talking about queries, because basically what you need to do is compose a response based on the response of multiple microservices. You do that by creating probably another artifact or by using an API gateway, an API management tooling that allows you to create this composition. One of the learnings when using this pattern is you need to think about, because the communication is synchronous, you need to think about how to parallelize the different calls you have in order to take the most benefit of it. And this is one of the common errors that I have seen when people begin with this pattern, not thinking about parallelizing. The second thing is thinking about availability, or the availability, the way it depends on the availability of the dependencies. And the resilient mechanisms that I commented a little bit before, the retries, the timeout, the fallbacks responses that we need to consider. That's why we think in another pattern that is the circuit breaker with a SYN request response. And this is something I have seen in some teams, right? We talk a lot about the circuit breaker, that you begin in a closed state, then you retry for failure. Then if you exceed the number of retries you configure, then you will return a fallback response. And then you will keep the circuit breaker half open until you try again. If it's still failing, but if you have success, then you will begin to the closed state. And what I have seen in this transition from REST communication or synchronous communication to an async communication are those scenarios when you don't have the dependencies, right? So I have a basic configuration, timeout, retries, and restart time. I have a command that is new customer registration. I have an API composer, and I begin like my calls. And it's really fast until I realize the last dependency is not working, right? So all of this configuration will come into play. Then I will try for a second time, and then I will know that I need to return a fallback response. What I have seen in the REST like HTTP codes is to use something that is meaningful, right? So you are the UI also can provide to the end user a message according to it. So I process this customer registration and it's in progress, but there is a missing piece. There is a failed dependency, and I can provide the user this information in a good way. And then I can add an asynchronous mechanism at this step and being resilient at this point and notifying asynchronously the client about the update. When we think about this synchronous versus asynchronous communication, in general terms, what I have seen is API composition is simple to implement, especially when you are migrating in a REST fashion, you're moving from a monolith and you're moving to microservices. It can be helpful simple to implement, especially for queries. You can also have these hybrid solutions, right? When you can actually implement and be resilient to some scenarios, but you need to consider what is the business use case that you want to solve in order, what can you be resilient of? I'm going to go directly to events, and I will provide some examples of the different projects I have worked on. We need to think the same thing I commented before when we are talking about the query and the API composition and the fact that you need another artifact to make the composition of the response. When you think about the commands, you need to have a transaction that is distributed and that is composed of different transactions, and this is the Saga. I have transactions that needs to be composable. I have a pivot transaction that will allow me to move in one another direction. And finally, I will have one transaction that needs to be retriable because I raised the pivot condition and the only possibility is to retry. I need to model this in my architecture that is distributed the same way I will do with a two-phase commit in the monolith. And for applying this, the first option I have is the Saga orchestrator. I have seen this. This is a real example of a team I work on. We were working in the notification of to the end user based on the preference. So we have the Saga orchestrator that is a persistent object that implements a state machine that is responsible for the invocation of each of these participants. So I begin the communication and I begin to save different status I get from this notification. The first one is enriched, but in the case this fails, I will set a by default configuration that, for example, is sending the notification by email. The next status will be the created. Then I will queue this notification and it will change the status. And then I will complete the flow depending of the mechanism I use to send the notification, and I will update all of this status. So this is the way a Saga orchestrator looks like. Evidently, it provides me more benefit than a synchronous REST communication, that is more the API composition I showed before. The other option is the Saga choreography. In a Saga choreography, the coordination, instead of having this state machine, this central triggering of the calls to the different participants, I have a message broker that ensures and guarantees the delivery of the messages, but then each of the microservice is responsible for handling the communication or the messages that other microservices are publishing, right? So in the case of the client registration that I showed a little bit before, I will have this user information registration. I will have also the customer information, and I will have loyalty account information. So I will begin with this registration of the user, and I will need the rest of the microservices to react to these events and do and complete this transaction that I talk about internally in their own context. So each of them are responsible of the consistency independently. In general terms, what I have seen recently in the clients I have worked on, it's we prefer centralized decision-making from the perspective of the testability and the control you have in the coordination logic, because it is a centralized decision. It is more like a request response that is asynchronous. It's like moving from the synchronous communication to an asynchronous in a controlled way. The choreography, on the other hand, I think it requires more maturity in terms of the teams that are involved, because you need each of the teams that has these microservices to ensure they are taking care of the consistency of the overall transaction. And finally, I would like to talk about CQRS and event sourcing, and I am covering these different patterns in the way I'm doing because it's more or less the evolution I have seen in the clients. When we talk about CQRS, in all of my talk, if you realize, I always use the query and command separation in the examples I provide. The idea of CQRS is basically do this segregation of command and consultation responsibilities. To use events to update a query replica that I can use for the consultation. And the good part of it is, you can persist the events instead of persist the status, right? And that is the reason why CQRS and event sourcing usually are seen together. You can have CQRS without having event sourcing, but because you are using events in CQRS, it's probably simple for you to use an storage based on those events. A real example I'm going to show you that it's similar to the previous one I showed. We will have a data model for commands that generates events. Then I have a message broker. My message broker also provide the events to the data model for queries. And it can be event sourcing or not. Allows me to get the orders information with the payment information used because I have an order history materialized view. I see especially in the orchestration versus in the two Saga parts, choreography versus orchestration, right? In the choreography option, I think this is really helpful to have these materialized views as a way to consolidate the status that belongs to multiple events that are generated in different microservices. So I see this pattern more connected with that option. In terms of trade-off, as I commented before, we talk about the API composition, inefficiency in queries, and this is a good option to split the command and query, but there is a cost associated with the replica, definitely. In the size of the event sourcing, the complexity, it's inherent to the fact that we are now saving events instead of saving the status. On the other hand, the benefit of having it is if you want to see the history of all of the different changes, you will have it. The final thoughts I want to share of this talk that I know it's more general of the journey I have seen, it's not everything needs to be microservice. I don't need to strangle everything in my monolith. I need to think about what provides me more value. I can have hybrid solutions. I can use a synchronous mechanism without changing completely my architecture, everything to become asynchronous. And also consider if you are thinking about a choreography, if your organization is mature enough, right, to have that level of responsibilities distributed between these multiple teams. And finally, even if you decide to have a synchronous, a Saga, to have CQRS and event sourcing, there are some common things that you need to think of that are related with the DevOps culture, like observability, continuous delivery, and provisioning, that are essential. And thank you very much. If this sounds familiar to you, it's some of the information I provided to you, probably some of this pattern you apply, but you didn't know how they were called. If you are facing similar challenge, maybe you are considering an event-oriented architecture for the solution you're working on, I'm available to talk.